definitions we have made. So same thing, let me put once again. So first we'll go for what all we discuss will be streamline flow. All our syllabus revolves around the streamline flow only. That you have to keep in mind. Huh? So it's a streamline flow. What is the some I gave definitions, no, like this. There's the one very classical example of so this will be the what we'll say. What are these arrows? The velocity of the different molecules, velocity of different layers of the liquid here. Then after this, we went for one more. If this is the some point P will take here. No. Now this is the liquid A or different molecules of the liquid. So they are having now different speed. Okay, let it be this one. But when they every layer, also like every layer, or if every molecule, if different molecules of the liquid, if they pass a given point with the same velocity, then it's said to be streamline flow. They may have a different speed, but they will arrive here, they must have the same speed. Suppose say this is 10 meter per second. Or need not, just like it. If different molecules, if they arrive at a point P with the same velocity, see, they may have different velocity here. But when they arrive at point P, they must have same velocity. This was the meaning of streamline flow. Now, when A passes here, so if the velocity is like this, it's a streamline. B also passes, if the velocity is towards it. C also passes velocity to same direction, and it must have same speed here. So what is the condition we can put? If different molecules arrive at a point with the same velocity. So there's the one basic idea of a streamlined flow. A streamlined flow is what like you can say better, it's like a ideal one. Actually what happens, a turbulent flow will take place, or better say like we have to put a condition for streamline to occur. Let me not use word ideal. Let me say that some conditions are to be satisfied. First, there's one way of putting that one. The diagrammatic representation we do show like this. There's a diagrammatic representation. Fine. This is now. Sorry, is it like they must arrive with the same speed or same velocity? Same velocity. All particles must also follow the same speed and direction at a point P. Suppose the velocity of the liquid at point P is 10 meter per second along x-axis. All the particles arriving there must have speed 10 meter and direction should be along positive x-axis. Then only it's said to be streamline flow. If the particles arrive at point P with a same speed but different direction, it will become a turbulent. Okay, so if different molecules arrive at a point with the same velocity, then it's said to be streamline flow. So now after this, we'll go for turbulent flow. So turbulent flow you can see the velocity of different molecules. They'll be in different they'll be having different directions. So then here, if different molecules arrive at a point with different velocity, it is said to be turbulent flow here. So what is the velocity of, say like a velocity of point P? Velocity of the liquid at point P should be 10 I cap meter per second. So what should be the velocity of all these particles? when they're crossing point P, don't put a condition that all the time. When they're crossing point P, should be 10 I cap meter per second at point P. Finish, or are you able to get this one? Now they may have different velocity here, but when they cross point P, they must have the one fixed velocity. Then said to be streamline flow here. A good example, a good example. Suppose say here, this will be very useful thing for you. Okay, I do have. Tell me like, what is the velocity of particle here? The best example is what I'm giving. They may ask you questions on based on this also. You have to be very careful in exams. Let me push it here. No, these are the particles. We'll take it. These are nothing. So what is the velocity of the liquid here at one, and this is a 2, no? So V1, if it is say like a 8 meter per second, speed of the particle at 2 will be say like a 3 meter per second. No, they are arriving. So at point 1, so these are the velocities of the particles, VA, VB, VC. Tell me like, what should be the speed of the particles now? Go back to the streamline. No. At point 1, what should be the speed of particles? This will be 8 meter per second. Let me write it here. At point 2, the speed of particles should be 3 meter per second, 3 meter per second, 3 meter per. Then only decide to be streamline flow. Are you getting no idea? Don't think that all the particles must have same velocity, but at a given point. Now what is the velocity here? I don't know what will be that one. But when they arrive at point 1, they must have velocity 8. When all 3 particles, when they pass through point 2, they must have velocity 3 meter per. Then decide to be streamline flow. Getting this simplest explanation is what I'm giving. In books, you have theoretical. There's a practically, there's one of the method of determining streamline flow. Okay, now the same, sir. Can you explain similarly for turbulent also what actually happens? We'll copy this. Yeah, we'll put it here. For turbulent, in turbulent flow, when they arrive, when particle 1 arrives, it may have 8. This may have 9. This may have say like a 6. Anything that one. Here it will have 3. This will be say like a 2. This will be say like a. Sir, how it is possible? That's what the turbulent. They may arrive at the same speed, but they may arrive at a different directions. Then also it is said to be turbulent. Even it can also be happen like this. Okay, all they arrive. I think I'll put directions also. What do you mean by red color arrow? Towards right. So here it may be like this. Now you see this. So there's a very classical example of what is turbulent flow. That one, all points they're arriving. So different particles, what happen? ABC, they're arriving at point one. Okay, speed is same, but look at the direction. The directions are different. Then that will be turbulent flow. At two, when they arrive, they have same speed, but what about the direction? They're different. So then it's said to be turbulent. So what we should bother, even not only speed, if they're having different speed, definitely it's a turbulent. Sometimes what happens is all are having same direction again. It's a very good example is what I'm giving. So not only speed, what you should bother, even the directions also. A good example, when rain comes, the water, the way how it flows on a on roads, no, it's a turbulent flow, that one. Or if you take the oni, a thick oil, and if you just pour oni bottle, if you just open the lid and try to pour honey in some other bowl, something, how the honey will flow? Honey will flow gradually, that is a streamline flow. If you open tap, that what when if water coming with more force, then it's a turbulent flow. But you open tap very gradually, or say like a small opening you make it, and the water falls gradually, that will be a streamline flow. When you go for full opening, the water will rush, no, there is a turbulent. But you just give small opening, let the water fall gradually. So this is, I think, a few more examples I wanted to share you. Of course, taps changed a lot. So I'm going traditional one. So if there are two taps are there, the water here, if it falls like this, then this will be a streamlined flow. Then instead what will happen, the water what will happen, will rush, no, like this. If you open it full, this is turbulent. Okay, fine. These are the several examples. So they may, in exam, they may give diagram like this, so you have to be careful. A student opens a tap, that then he sees the flow of water in the first diagram, and the next in second diagram. Then they'll ask you like, which one is streamlined, turbulent? So this should be the turbulent, because you see that any definite open, it will spread like this. This called like a turbulent here. Even rotation also, you can see that one. I'm showing these arrows here. So if there are any rotation of liquid occurs, then it must be turbulent. I think this you can see naturally when streams, rivers, no, or even during rainy season, we can see water will be rotating at certain point. It's a good example of turbulent flow. Fine. So this is one basic background is what we have is set up here. Okay, let's get into we are starting now, the viscosity here now. So if you look at the liquid,